Good morning, dear students. Last class we discussed what is the coordination compounds, what is the ionizable sphere, what is the double charge and coordination compounds, what is the ionizable sphere, coordination sphere. Right? So central metal atom, generally it is having the transition metal, generally it is having the vacant d orbitals. So the ligands are electron excessive species. They donate the electron pair to central metal atom through coordinate covalent bond. Through coordinate bond. That's why we are calling as coordination chemistry. This coordination sphere does not ionize in the water. Still, these ligands and central metal atoms still contact in the water. So ionizable sphere ionizes, coordination sphere does not ionize. Central metal atom acting as a Lewis acid, ligands acting as a Lewis bases. So far we discussed. Based on the how many number of atoms are donating, based on the how many number of atoms are donating, on the basis the ligands are classified into different types. Based on the how many number of atoms donating, the ligands are classified into different types. Monodentate ligand, bidentate ligand, tridentate ligand, tetradentate ligand, pentadentate ligand, hexadentate ligand. So, based on the how many number of atoms are donating. Ligands, what is the nature? Donating the electron density. That electron density, how many number of atoms are donating? So mono, what is the meaning of mono? One atom is donating. Monodentate ligands. Monodentate ligand. That means one atom is donating the electron pair or electron pair to the central atom. Suppose examples, negative, this one again classified into negative monodentate ligand, neutral monodentate, negative monodentate ligand, right? One is negative, that one is, the next one is neutral monodentate ligand. Negative monodentate ligand, so negative monodentate ligand. So fluoro F minus, fluoro Cl minus. How many negative charges? Only one negative charges. One atom, only one negative charge. So one atom donates the electron density, electron pair to the central metal atom. Fluoro, chloro, bromo, iodo, hydroxo, OH minus, hydroxo, Cn minus, cyano, Nc, the minus is present on the nitrogen. Here the negative charge present on the carbon, here negative charge present on the nitrogen. Isocyano, SCN minus, the negative charge present on the sulfur. Thiocyano, right? NO2, nitrito, so NO2 nitrite, NO3 nitrate, NO3 minus, nitrato, right? So these are the negative ligands. Once again, fluoro, chloro, bromo. You should at least practice 2 to 3 times, right? If you practice, then only you will understand coordination chemistry in the better way. If you know ligands, you can write the nomenclature very well. If you write the nomenclature, you can understand the theories very well. Right. Fluoro, chloro, bromo, iodo, OH. OH minus, generally OH you can call it as H plus OH minus hydroxide, right? So you can call it as hydroxo, Cn minus cyano, Nc minus isocyano, SCN minus thiocyano, NO2 nitrito, NO3 minus nitrito. These are the negative monodentate ligand. What is the neutral monodentate ligand? H2O, aquo, NH3, amino, CO, carbonyl, NO, nitrosyl, nitrosyl, CH3NH2, methylamine, So water, in the water it is only oxygen donates, not hydrogen. In the ammonia, nitrogen donates. Mono, neutral. These are no charges, but neutral means there is no charges. But monodentate. What is the which one donates the electron pair? Oxygen donates the electron, not hydrogen. Oxygen donates the electron pair. Here nitrogen donates the electron pair. Here carbonyl. Right? So water, aquo, NH3, amino, CO, carbonyl, NO, nitrosyl, CH3NH2, methylamine. These are the monodentate ligands, negative monodentate and neutral monodentate ligands. The next one is bidentate ligand. Bidentate ligand. So how many atoms are donating the electron pairs? 2 atoms are donating the electron pairs. So in this one also negative bidentate ligands, neutral bidentate ligands. Carbonato CO3 minus 2. What is this one? Carbonato. So how many atoms are donating the electron density? 2 atoms. Suppose if you write carbonato C double bond O minus. What is this one? I am writing it, right? So carbonato structure. So how many atoms are donating? Here oxygen atom is donating. Here oxygen atom is donating. So 2 atoms are donating. 2 atoms are donating the electron pairs. That's why it is a bidentate ligand. C2O4 minus 2. Oxalato. Right? Oxalato also bidentate ligand. SO4 minus 2. Sulfato. So when you come in the nomenclature, you have to write it as a sulfato. Actually, it is a sulfate ion, but in the coordination chemistry, it is an oxalate ion. But in the coordination chemistry, you have to write sulfato, oxalato in the nomenclature. That's why I am writing oxalato and sulfato carbonato. Actually, what is the CO3 minus 2 ion in general terms? How can you call it? Carbonate ion, sulfate ion, oxalate ion. But for in the nomenclature, generally we represent as a carbonato, oxalato, sulfato in the coordination chemistry. Right? These are the 3 bidentate ligand. What is the neutral sulfato? If you see sulfato, how many atoms are donating? Two atoms are donating, right? SO4 minus 2. How many atoms are donating? Two atoms are donating. That's why it is a negative. Why it is a negative? There is a charge on the ions. There is a charge on the ion. That's why it is a negative. Two atoms are donating bidentate. These are the donating electron excessive species. That's why you can call it as ligands. What is the neutral bidentate ligand? Ethylene diamine. Ethylene diamine. Ethylene diamine. So ethylene diamine CH2 CH2 ethylene, right? So you can call it as En. Generally in the nomenclature ethylene diamine they represent as a small En, ethylene diamine. What are the donating atoms? Nitrogen is the donating atom here. This nitrogen is donating atom here. So how many donating atoms? Two donating atoms. That's why it is a neutral bidentate ligand. Neutral bidentate ligand. Ethylene diamine. So two carbons, right? So two amines, diamine, ethylene diamine, right? Ethylene diamine. So nitrogen is donating, this nitrogen is donating. There is no charges on the molecule. That's why it is a neutral. Two atoms are donating. It is a bidentate. It is donating. That's why it is a ligand. Neutral bidentate ligand, ethylene diamine. In the short form, they represent as a En. In the nomenclature, they will write it as a En, not they write it as a ethylene diamine. En means ethylene diamine. In the negative, one more also there, that is CH3. They have given in your book CH3, CH2, CHOH, CH3. Acetyl acetonato. This one is the acetyl group. This one is the acetonato. Acetyl acetonato. Acetyl acetonato. Right? So acetyl acetonato. This one is the donating group. This one is the donating group. So acetyl acetonato is also bidentate ligand. Next one, tridentate ligand. Tridentate ligand. So tridentate ligand they have given neutral. So En is the bidentate. Diene means diethylene triamine. Diethylene triamine. Diethylene triamine. So CH2. So this one is the ethylene diamine. If it is NH2, ethylene diamine. Diethylene means it must be NH. So you have to write one more CH2. Right? This one is the NH2. So how many atoms are donating? Three atoms are donating. So just you need not worry. Just it is ethylene, one more ethylene. So this is one more ethylene, diethylene triamine. How many nitrogens? Three nitrogens. 1, 2, 3. Three nitrogen. That's why tri. NH2 you can call it as amine. NH2. Triamine. Diethylene CH2. This one is the ethylene. Both are ethylene, right? So the remaining three are triamine. So or you can write it as a NH2. Some books they write it as a CH2 OR. CH2 taken twice, that means two times at the same time. They write it as like this, NH CH2 to NH2. So either you can write it like this or you can write it like this. Both are same. Diethylene triamine. This one is a tridentate. Why it is a tridentate? Three nitrogens can donate the electron pairs. That's why it is a tridentate. It is a ligand donating the electron density. How many atoms are donating? Three atoms are donating. That's why it is a tridentate ligand. Tridentate ligand. What is the example? Diene. Diene. But normal En is the ethylene diamine. Ethylene diamine is the bidentate neutral. Diene is the tridentate ligand neutral. You have to remember. So tetradentate, triene, triethylene, tetramine, diethylene, di vachinappudu it comes dry. It is a tri, right? So ethylene, if it is simple ethylene, it is a diamine. So right. So the next one is tetradentate ligand. Tetradentate ligand. Triene. Triene. So what is a triene? Triethylene, tetramine, triethylene, tetramine. Triethylene, tetramine. So very simple. So you can write it as NH2, triethylene, CH2, 2 times NH, again CH2, 2 times NH, again CH2, 2 times NH2. So how many atoms? 4 atoms. 1, 2, 3, 4. All these 4 nitrogens are donating. Tetramine. So how many ethylene molecules? 1, 2, 3. Triethylene tetramine is the tetradentate ligand. Triethylene tetramine. This is one ethylene, one ethylene, one ethylene. In between ethylenes, there is a 2 NH groups. Right? So how many NH group nitrogens? 4 nitrogens. 4 nitrogen can donate the electron pairs to the central metal atom. That's why you can call it as tetradentate ligand. Tetradentate ligand. So triene means triethylene tetramine. Diene means diethylene triamine. En means, so you should not confuse. En, diene, En, triene. En is the bidentate. Diene is the tridentate. Triene is the tetradentate. Ethylene, if it is ethylene, diamine. Diamine. So diethylene, so it is 1, this one is 2. Right? Ethylene is the 1, amine is the 2. Diethylene, di means here is triamine. So you have to easily 1 ethylene, 2 amines, 2 ethylenes, 3 amines, 3 ethylenes, 4 amines. Triethylene, tetramine, 3 ethylenes, 4 amines, 2 ethylenes, 3 amines, 1 ethylene, 2 amines. Right? So you can easily remember En is the bidentate neutral, diene is the tridentate neutral, triene is the tetradentate. Ethylene 1, 2, 2, 3, 3, 4. Ethylene diamine, diethylene triamine, triethylene tetramine. So these are the bidentate, tridentate, tetradentate. There is a hexadentate ligand. So the structure is not required for hexadentate. So just remember EDTA, hexadentate, EDTA. Ethylene diamine tetraestic acid. Ethylene diamine tetraestic acid. So EDTA is the hexadentate. How many atoms are donating in the EDTA? 6 atoms are donating the electron pairs to central metal. It is having the ability to donate the 6 atoms. That's why you can call it as hexadentate ligand. These are the classification of ligands. First one is the monodendate ligand. You have to remember, right? You have to write 2 to 3 times. You will easily remember, right? Monodentate negative ligands, neutral ligands, bidentate negative ligands, neutral ligands. So tridentate, tetradentate. From bidentate neutral onwards, you need not remember. One is En, tridentate, diene, tetradentate, triene. Right? So just if you practice more on this one, you will concentrate. You will easily understand the nomenclature. So the next one is ambidentate ligand. Ambidentate ligand in the same classification of ligands. The next one is amphibian. Amphibian means both. It is live in the water as well as in the land. So ambi means it is two. It is acting as a two. It can utilize two donor atoms. A unidentate ligand containing two donor atoms. It can utilize either of any one donor atom. It is simply you can. What is the meaning of these lines is it is having two donor atoms. It can utilize any one of those donor atoms, right? So you can call it as ambidentate ligand. So suppose if you take one example, so here nitrogen nitrito, nitro, NO2 minus nitro. So here nitro, you can call it as nitrogen. In the same metal, it can donate the same. This one is a nitro, this one also NO2 minus. Here oxygen is donating the. So you can write. So here oxygen is donating the electron pair to the metal. This one is NO2, this one also NO2, but in this one nitrogen is donating the electron pair to the metal. In this one oxygen is donating the electron pair to the metal. So what is the meaning of this one? It is having the two donor atoms. One is nitrogen is acting as a donor atom, oxygen is acting as a donor atom. Both are acting as a donor atom. It can utilize either of any one of those donor atoms for bond formation is known as ambidentate ligand. So when you are writing this one, you have to mention nitrito N. That means here nitrogen is donating the electron pair. In this one, what you have to write? Nitro oxygen. Right? This is one more example. Several times they asked in the examination what is ambidentate ligand. Give an example. Alright. So the next one is cyano and isocyano. Here Cn is donating the electron pair. Right. So cyano. Same formula, but in this one, which one is donating? Nc. Nitrogen is donating. So it can utilize. If it is utilize carbon, you are calling as a cyano. If it is utilizing nitrogen is donating. You are calling as a isocyano. So it can utilize both donor atom. When it is utilizing carbon, you are calling as a cyano. When it is utilizing nitrogen, you are calling as a isocyano. So these type of ligands you can call it as ambidentate ligands. Coordination number. So what is in the continuation of terms? Next one is the coordination number. The total number of ligands attached to the central metal atom in the coordination sphere. Right? You have to consider it as a sphere. Right? This one is a metal. This one is a metal. This one is a ligand. So how many ligands are attached to the metal atom? If it is 6, if it is 4, how many ligands are attached to the metal atom in the coordination sphere? How many ligands? How many ligands are attached to the metal atom in a coordination sphere? You can call it as coordination number. You should consider within the square bracket ligands only. So if it contains only monodentate, suppose if the coordination sphere contains only monodentate ligand, so how do you calculate coordination number? 1 into number of monodentate ligand, monodentate ligands, that gives the coordination number of that complex, that gives the coordination number of that complex, coordination number C. So coordination number I am writing as a CNO, coordination number. So that means if the coordination compound, these ligands are only monodentate ligands, so you can call it as 1 into number of monodentate ligand that use the coordination number. You will understand by taking the example. If it contains bidentate ligand, bidentate means what you have to do? You have to multiply with 2 into number of bidentate ligands. Number of bidentate ligands. Suppose bidentate ligands are 3. What is the coordination number? 6 is the coordination number. If the monodentate ligands are 6, what is the coordination number? Coordination number is the 6. Right? If the bidentate ligands are